Hi, Ken from Tanning Pit Repair Guide. So what is a transformer? Well, a transformer is a clump like this, or it can be much larger. What you'll use it for is when you want an AC voltage that is different than the one that you have from the wall in the tanning salon. So let's say you want to create a circuit, a smaller circuit that runs on something very little like 12 volts. You're going to have to step that way down. And that's what happens inside of many electronic gadgets. You will find one of these and perhaps even smaller. So how does it do that? And first of all, I want to clarify that you can't do this with DC voltage, like the one that comes from a battery, something like this. It requires that you have this AC voltage because, so when you have, let's take a line here, there is minus. And then what an AC voltage is doing is that it's alternating positive and negative, like positive, negative, positive, negative, positive. So that's why it has that name. It's called alternating current. That's because of that. And because it's doing this change, once you put wire around a core, like metal, like in one of these here, you create a magnetic field. And this magnetic field, you can actually put another set of windings on it and draw a current out of it. So you'll use the magnetic force as a way of transferring power. So let's take this example here. We'll have a stick here and a stick of metal here. So let's say that you take your line voltage here. Let's say that it's 220 volts, and you take some wire and you run that around and around, like you wind it around this rod like 100 times. 100 full rounds of wire around this core. And now let's go on the other side, on the other rod here, and do the same thing here. It turned out to be different. Sorry. And you only make like 10 of them here. 10 rounds. Right now there's no connection between the two. So nothing would happen if we put on power here. Nothing would happen over here. But the moment, because you're creating this magnetic field, these eddy currents over here, if you went and connected this magnetic field and through metal, this iron, you connect the other side magnetically. And to make that extra strong, you might as well use the space in the middle here. So this is one. You do that with a bunch of like metal plates that you like stick together and create this big metal core. And so now you got this magnetic eddy current field that you have created over here. That is out in all of this metal here. And the funny thing is that this eddy current will now, where you generated it over here, you can actually, it will actually generate in reverse basically out into the wires. So now you can pull voltage out of these lines over here. Out of this wiring over here, you can pull voltage. And we said we did 100 here, and we did 10 over there. There's actually a really easy way to calculate it now, when you know this. And that is that you will have just 10 times less. So if you had 100 over here, you will have 220. And now we have 10, you will have 22 volts over here. And this is actually a very common way of creating a transformer, by inducing this field over here with your line voltage, and then what's called a load you have over here. And that's how you step down the voltage, by having less windings over here. There's a way to calculate how to exactly make how many windings you should be having over here, and then you can from there calculate the your windings over here. That's more technical. I just want to give you the concept of this. So this is kind of a funny, this is my twist on explaining this concept. There's a lot of videos explaining this concept, but I wanted to give you this angle on it, this start on it instead. Don't know if it's gonna work any better for you, but this is definitely an alternate route to it. So the names of these actual things here is that what you call this over here, where you have your line voltage coming in, you call this primary. And where you have your load, your actual circuit that you need the smaller voltage for, you call that your secondary. And this particular type of transformer here is one like this. This is the very traditional one, where you have you can actually see how, like, you have windings like divided with these two plastic dividers. So the actually two what's it called? The two transforming parts is actually placed inside of here. You could do that, but that would be harder to understand when you're explaining it. And this makes a little bit more sense because you kind of divide it out. But you can imagine if you put the windings in here next to one another, you will have the same thing. It's all that really matters is that you don't have any electrical connection between these two sides, but you have only a magnetic connection between them. And that magnetic force is what's generating the secondary voltage, and where you are putting your actual load for that circuit on there. This is how a transformer works. I hope it made sense a little bit. And it's some kind of an alternate way to understand transformers. Ken from 10ing Bit Repair Guide. Take care, guys.